already started with inertia. Okay. So according to our last discussion, what we have written was if external force acting is 0, if external force acting is 0, then object continue to be in its state of rest or motion. Okay, so this is what we have discussed in our last class. If external force acting on an object is 0, then object continue to be in its state of rest or motion. If it is in the state of rest, it continues to be in state of rest. If it is moving, then continuously should be in the uniform motion, but no acceleration. That we have to remember. Okay. So, or if you want to make it simple, you can simply write it's inability of an object. It's inability of an object. What you can say? It's the inability. It is inability of an object to change itself or to change its inability of an object to change its state of rest or motion. Okay. Its state of rest or motion. Its state of rest or motion. Okay. So what it is? Okay. So this simple definition you can go in this one, or this is so very simple. So whichever you can follow. So in this inertia, we can divide into types. Okay. So that is what we can call it as inertia of rest. Okay. Inertia of rest or inertia of motion. So let me write it. Inertia of rest or inertia of motion and inertia of direction. Inertia of direction. So we can divide this inertia into three types. One is inertia of rest, another is inertia of motion, and third one is what? Inertia of direction. Okay. So how we can define this thing? How we can define what is inertia of rest, or what is inertia of motion, or what is inertia of direction? Okay. So inertia of rest means it is the inability of an object. It is the inability of an object to change its state of rest. Okay. So name itself is saying inertia of rest. Inertia means what? It's the inability of an object. About what? About rest. If suppose a body is at rest, it is unable to change its state of rest by itself. Okay. If no external force is acting, then it cannot change its state of rest. So that we call it as inertia of rest. Okay. So if you look at the examples of this one, so suppose you are moving in the bus, okay, or if you are moving in the vehicle. So what will happen? Suppose you are sitting on the chair. Okay. Suppose bus is at rest. Okay. Bus is at rest. Suppose if suddenly it started moving, so what will happen? So the lower part start moving, but upper part want to be at rest only. Okay. Upper part want to be at rest only. So suddenly when bus start moving, the passenger, what will happen? He move in backward direction. Okay. Actually he is not moving. His body want to be there in the state of rest. So that is what we call it as the inertia of rest. Okay, so that is the best example for inertia of rest. Or if you take the a mat. So suppose if you want to clean the mat, so what will happen? Suppose there are the dust particle on this one. So what you can take a stick and beat this mat. Okay. So you can take a stick and beat this mat. So what will happen? So suddenly when this mat started moving, so when this mat started moving, so these dust particles started falling down. So these dust particles started falling down. Why they are falling down? When that mat started moving. So only mat is moving, but what about the dust particles? Dust particles want to be there in state of rest because they are unable. That is what inability of those dust particles to change its state of rest. Okay, so that is why they want to sit there only. Suddenly what happens when the mat moves? So they are sitting there, but there is no what you can say, there is no place to sit there. So what will happen? They start falling down under the gravitational force. Okay. So similarly, if there are the branches of trees, so there are the leaves. So what will happen? So these leaves are now at rest. Suppose somebody start the disturb, or somebody disturb this branch of a tree. So what will happen? When they shake this one, when you start shaking this one, so what will happen? Only this branch start moving, but what about these leaves? Leaves want to be there at state of rest. So when the branch moves, leaves want to be continuing in state of rest. So what will happen? There is no place, or there is what will happen? They start falling down. There is no support for that to be there. So what will happen? So these leaves started falling down. Okay. So this is what the natural example for the inertia of what? For the inertia of rest. Okay. So it's the inability of an object to change its state of rest. So similarly, inertia of motion, as the name is suggesting, just what it is, the inability of an object to change its state of motion. Okay, it is the inability of an object to change its state of motion. Okay, so that is what. So if a body is continuously in the state of motion, so suddenly it is not possible for a body to come to rest, or to change its state of motion to the rest. That is what we can say, that its inability. It is not able to change itself. If suppose something is moving, unless some opposing force act on that one, it can't stop. Okay. So that is what we call it as the inertia of motion. So if you look at the example, suppose you are sitting again in the bus or some vehicle. So what will happen? You are in continuous motion. Okay. When suddenly brake is applied, so what will happen? So your lower part comes to rest, but what will happen? Your upper part is still in motion, because it can't suddenly come to the rest, because it's inability of that object. So that is what happens. So you feel like falling down. Okay, you feel like falling down. Here what has happened? You felt like moving moving in backward direction when bus start moving. So here bus is already moving. When brake is applied, you feel like you are falling forward. Okay. So this is what we call it. You can take as an example for the inertia of rest. Okay. So these kind of examples you can see in your day-to-day life. Suppose a stone is suppose if you take the example of say suppose suppose the bus is moving. Okay. So if you want to get down from the bus, so what will happen suddenly when you get down from the moving bus? So what will happen? You have to run for some time because your body is in motion with that bus. Your body is still in motion with that bus. So that is why when you get down suddenly from the bus, so what will happen? Your body is coming in contact with the earth, which is at rest. Okay. So suddenly it is not possible for the body because it is unable to suddenly change its state of motion to the rest. So that is what will happen. If you suddenly simply jump from there, you will obviously fall down in forward direction because bus is moving in a forward direction. So that is why to avoid that falling down, what you have to do, you have to run for some distance. You have to run for some distance in the direction of the motion. Okay, not in the opposite direction. Okay, so that is what the best example for the inertia of motion. So similarly, inertia of direction, as its name itself is saying, so it is what? It is the inability. It is the inability of an object. Inability of an object to change its state of to change its direction. To change its direction. Okay, direction of motion, or simply you can say to change its direction. So when something is moving, suddenly if it changes the direction, the people or the bodies connected with that one will not suddenly change. Suppose a vehicle is moving in curved path. Suppose what will happen if a vehicle is moving in a curved path and you are sitting in that bus. Okay. So when bus suddenly move in this direction, when suddenly changes the direction, you feel like falling on that side, or you feel like somebody push you in that direction. Okay, so you are moving away from the center. Okay, if bus is turning turning in this direction, so what will happen? You are at rest in this direction. Okay. You are sitting in this direction. Suddenly, when the direction of bus changes, so what will happen? You want to be there in that state of direction only. Okay. So suddenly, when bus changes, so what will happen? Your body is unable to suddenly change its direction. So you will feel like that you are pushing away from the center. Okay. So that is what the day-to-day life experience of the inertia of direction. Okay. Similarly, suppose if somebody tied a stone with a thread and they are rotating it, okay. So if this thread is rotating with from somebody, so what will happen when suddenly this thread is cut at the middle or somewhere? So what will happen? It will not move in this direction. It will move in this direction because at this point it's the direction of motion is here. Okay, so it suddenly can't change its direction of motion. Okay, that is also an inability of an object. Okay, so to change its direction. So these are the few examples of the inertia of rest, inertia of motion, and inertia of direction. So totally, what is the conclusion? It's inability of an object to change its any kind of, it may be a state of rest or motion or direction. Remember, unless external force is applied. If external force is applied, then no need to worry about all those things. Okay, so this inertia will not come in action. Okay, so then how we can measure what is the physical quantity through which we can measure this inertia. So suppose you are having say some object over here. Suppose a small object is used. Okay. Suppose a small object. Say bicycle. Okay. So better example is, suppose there is a bicycle. Suppose somebody asks you to move this bicycle. So what will happen? You will apply the force. Okay. So you will apply the force. So what will happen? The bicycle will move. You are applying say some 10 Newton of force. That's all. Okay. You are applying some 10 Newton of force. That's all. So what you are doing? You are changing state of rest to motion. You are changing a state of rest to the motion. That means what has happened? You are just removing the inertia. You are just removing the inertia. It was at rest. Now you are moving. That means you are removing the rest with the help of only 10 Newton of force. Okay. So instead of this one, suppose there is some road roller or something. Okay. Suppose a big vehicle is there. Then what you have to do? Suppose some bulldozer or something. Okay, you can take like that. So if somebody asks you to move this, okay. So you will apply some 10 Newton or some 20 Newton, say some 30 Newton of force. What will happen? Will you able to move this the huge body with the help of or yourself alone? It is not possible. You can make them apply say from 40 Newton or some 50 Newton. Will you able to change its state of rest to motion? It is not possible. You cannot change this state of rest to the motion. So you are able to change its inertia, but here you are unable to change the inertia of rest. You are unable to change its state of rest to motion, or you are completely failed to change its state of rest, or you are unable to change its inertia. So that means inertia depends on what? Will the inertia depends on its mass? Getting the point? So if less mass, so less inertia. So more mass means what? More inertia. Getting the point? So here less mass was there, so you can apply little force. That means inertia was less, so suddenly it can change its state. But here mass is more, so that is why inertia is more. So you cannot easily change its state or easily change its inertia or state of rest to the motion. So that is why less mass means less inertia, more mass means more inertia. So with the help of mass, you can measure the inertia. Okay. So inertia you can compare with what? Inertia you can compare with what? You can compare with mass. Getting the point? So mass is the measure of what? Inertia. So I can write one statement. Mass of an object. Mass of an object is the measure of what? Inertia. Okay. So mass of an object is the measure of what? Measure of inertia. Okay. Remember, if more mass, more inertia; less mass, less inertia. Before going for the Newton's laws of motion, one more thing we should be very much clear with, that is what? Very important, that is the force. What exactly force? So already we have discussed in our bridge course. Simply we can say it is a push or pull or an object. Push or pull an object is said to be what? Is said to be a force. Suppose if there is object, so if you push it, so it will move. Or if suppose there is an object, suppose if you pull it, okay. Suppose if you pull it, so it will change its position, or it is changing its state. Okay. So that is what we can simply say push or pull. If you want more about the force, you can go with the bridge force classes videos. So or simply we can say if force is not applied, position will not change. If you want to change the shape, then also you have to apply what? You have to apply the so shape will become like this. So by applying the force, what is changing? Shape is changing. By applying the force, what will change? Its position will change. It will come here. Okay. So by applying the force, what if its state may change? The solid may become liquid. Okay. So by applying what? By applying the force. Okay. So all these things can happen with the help of what? With the help of force. Okay. So I can write like this also. It is an external agency. I can write. It is an external agency. And external agency. It is an external agency which changes the state or position of an object. Okay, it's an external agency. An external agency which changes the state or position of an object. Okay, or simply you can write like this also. So what are the things the force can do? Force can change its position, or force can change its state of rest, or force can make body to move, or force can slow down or speed up the object. So what force can do is it changes the state of, or it keep a body at rest. It keeps a body at rest, or it can move. It can move a body, or it can change. It can change the direction. It can change the direction of a moving object, or it can change the state of rest to motion, or motion to rest. Okay, so all these things can be done by the force. Okay, so there are different types of forces. So mainly the force will be divided into what? Mainly force will be divided into two types. Okay, so what are those? So one is called as contact force, and another is non-contact force. Contact force and non-contact force. Okay. So there are two main branches of the force, or two main types of the forces. That is a contact force and non-contact force. So contact force means what? This force will act when two bodies comes in contact. Okay. So this force acts when two objects or bodies, when two objects comes in contact. Okay, comes in contact with each other. Okay, so similarly here, so these forces may act even when two bodies or two objects are not in contact. Okay, when two objects are not in contact. Okay, so means even though objects are at a distance, then also that force will act. Okay, and contact force it will act only when two objects comes in contact. Okay, so if we take the types of this one, so what are the things we are having in this? So the frictional force. So frictional force will come in action when two bodies comes in contact. Otherwise there is no friction, or simply we can say normal force. Okay, so again normal force will come in action when one body will come in contact with another body. Normal force means what? You have object kept here, the force acting on the body by the another body, or this will also act in downward. Okay, so similarly friction means if you are moving this direction, so that will opposes your direction of motion. That kind of force is what? It is the frictional force. This is what normal force, you can denote it by N. Okay, so these are the two best examples for the contact force, frictional force and the normal force. Okay, so similarly, if you look at the non-contact forces, if you look at non-contact forces, or if I take another example of contact force, that is what? Tension force. Okay, tension force in the sense when there is two bodies are connected by a string. So when these two bodies are pulled away, so there is a force acting between them. It will try to bring them back. Okay, so that is what we call as tension force. You will study more about that in coming lectures. Okay, so this is what the contact force, if these two are moving. Okay, so these are few types of contact force. Similarly, if we come to the non-contact forces. Okay, so if I come to the non-contact forces, in non-contact forces there are again types. One is very important, which is already you know much about it. What is that? Gravitational force. So gravitational force in the sense, so any force acting on the body due to the earth, so that is what we can call it as the gravitational force, which is always downward. Similarly, electrostatic force. So what electrostatic force will do? So if there are two charges, so there is a force. If positive charge, negative charge, so they will attract. Even though they are at a distance, then also there is a force between them. That is what we call it as electrostatic force. Similarly, one more I will take, that is what electromagnetic force, or simply say magnetic force. Okay, so if you take the N9S pole, so what will happen? There is a force between them. That is what we call it as magnetic force. Okay, so these are those are the few non-contact forces, and this is what the contact force. We have to study much more about the contact forces and non-contact force. That those all things we will see.